started. First, if you haven't noticed, we are next to train tracks. And what that means is that sometimes trains do go by while somebody's talking. If that happens, normally what we do is during the very loud part of the train, which is usually just a very short bit right at the beginning, we'll raise our glasses and say choo-choo and take a drink. Just do a little bit of a pause. One of the other announcements is that we have trivia throughout the talks, and we have prizes for this trivia. And let me tell you, I've been looking at the prizes, and some of you may have seen me like blabbing about them earlier. They are really cool. Really cool. We have meteorites. We have a autographed book by Bill Hartman. We have some really nice stuff. So the way we're going to do the trivia is that the speaker will ask a question, and the first person to raise their hand, so this is going to be civilized. So the first person to raise their hand with the correct answer will get the prize. But we'll have several trivia, so even if you don't get the first one, there's a chance to get the others. Okay, and we're going to have two speakers with a brief intermission in between. And so let's go ahead and get to our first speaker, who is Dr. Vishnu Reddy. He's a research scientist at Planetary Science Institute. There's actually an asteroid called Vishnu Reddy that's named after him. And he studies what asteroids are made out of on the Dawn mission, as well as with a lot of different observations from other missions as well. And he's going to be talking today about getting rich or dying. Let's give it up for Vishnu.
All right, everybody, make sure you have your beer glass full. I try and not to drink beer when I'm giving talks. So, yes. So just a brief introduction about me. What do I do for a living? Very loud?
Yeah.
Better? Okay. Is that if something is going to come and hit the earth, I tell what it's made of. Okay? So I got to deal with my neighbor. Okay? Every time I tell Larry that if you see me packing in the middle of the night and leaving, that's a sign. Okay? But usually it never happens because, I don't lose my sleep over these things. You shouldn't either. So just to give an idea, so I'm like the warm-up for Danny's talk. So she's going to tell the cool stuff. So I'm going to give you an outline, a brief introduction, what are asteroids, what are meteors, and then talk a little bit about fact and fiction that we deal with every day in real life. Okay? So if you guys go out tonight, obviously we have clouds thanks to the monsoon, which is a good thing. But if it were clear, if you go out and if you look at the night sky, the brightest object that you would see is Jupiter. Okay? So we can see this with our naked eye because it's big. Okay? Jupiter is the largest planet, right? And then a little later, you could also see Mars and Saturn. These are, the three major planets you can actually see in the night sky now, if it was clear. But you also have thousands of other objects here, which are called the small worlds. These are small planets, okay, or asteroids you can call them. A majority of them are going around the sun between the orbits of Mars and Jupiter. Okay, so here's a view of the asteroid belt. Okay, we're looking from the top down. Okay, sun is in the middle, right? You see, I have so many laser pointers just in case one fails. Okay, so here you got the sun, you got Earth is here, there's Mars, and then you see the belt of things going around. Here's the orbit of Jupiter. So what you see is that the majority of these objects, we've discovered about 700,000 of these quite a bit, right? They go around the sun between the orbits of Mars and Jupiter. About 14,000 of these objects get kicked into the inner solar system. We'll see how that happens, okay? And those are called near-Earth asteroids, the things that come close to the Earth. Very simple, right? Change my slide. I got the wheel of death. It always happens when an idiot gives a talk to the computer. We're getting there. Okay, you can see it. Okay, so these are called near-Earth objects. Okay, they're nothing but asteroids and comets. 99% of them are asteroids. About 1% of them are comets. Okay, out of these 14,000 objects, 1,700 are called potentially hazardous. This is the kind of stuff that journalists or some journalists make a living out of, basically trying to scare us. They're saying like we're all going to die. So, but these are potentially hazardous either because they come really close to the Earth or they're really big. Because small stuff coming close to the Earth, not a big deal. Big stuff going far from the Earth, not a big deal. Big stuff coming close to the Earth, bad deal. Okay? So how do you create these 14,000 objects called near-Earth objects? It's very simple. It happens, in a very simple way like this. So you got two asteroids in the asteroid belt. They bump into each other. Sparks fly. You got a lot of little tiny asteroids. These are actually called asteroid families. Okay? Right? And so these asteroid families, over time, they drift away from the family, just like meteors do as they get older. Right? And they get into what they call as resonances. Okay? These are like the freeways of the solar system. So you get to a resonance, you just get wham, you get really close, quickly you can get from the asteroid belt, which is between Mars and Jupiter, right down to very close to the Earth. Okay? So that's how you create near-Earth asteroids. And it's very similar for even, meteorites or meteors. So, I'll show you something. Here's a cast, not the real thing, but it's a cast of a meteorite. So what's in a name? Okay, you guys have heard about it. Meteor, meteorite, meteoroid. So it's nothing but a small asteroid. Think of it as really small. So maybe the size of, the stable. Okay? If it's floating free in space, okay, it's called a meteoroid. Okay? Just like an asteroid, it's a meteoroid. Okay? When a meteoroid hits our atmosphere, that's when you make a wish, right? You look at it, it's a bright streak in the sky. So that becomes the visible phenomena. That's the meteor. It's still pretty high up. It's 80 to 100 kilometers up above the atmosphere. That's how far you're seeing when you see a meteor. It's pretty impressive. Somehow this meteoroid shines as a meteor, survives it. Okay, either it slows down or it's big enough, it makes it to the ground, and I walk and pick it up. It becomes a meteorite. Okay. That's a simple thing. So I'm going to pass this around. It's not the real thing, but don't drop it. It's still expensive. Don't put it in your mouth because I've given this to a lot of kids and they put it in their mouths. And hopefully somebody will collect it at some point. Just don't walk away with it. All right. So how do asteroids look? We see pictures of asteroids. We see pictures of stars, planets, and stuff like that. When you go out in the night sky, you take a picture of the sky, asteroids just look like a dot, okay? Unless we have an asteroid that actually holds up a sign saying, I'm an asteroid. So you really cannot tell the difference between a star and an asteroid from a picture, okay? But we have different tools we use to try and find asteroids. The most famous one, okay, it's on Catalina, it's Catalina Sky Survey. It's at Mount Lemmon, okay? It's the most productive telescope that is discovering asteroids. More than half of the near-Earth asteroids ever discovered were discovered from near Tucson. Isn't that cool? Okay. So how does Catalina find these asteroids? Okay. So we're going to talk about a little bit about technique, and then we'll play a game. Okay. Because otherwise it gets boring. So what you do is think of this. Okay. For the example of this, you guys are all stars. Okay. For a moment, just think you're stars. Who's going to be my asteroid? Let's think. Sandy, you're my asteroid. Sorry. Sandy is my asteroid, okay? So I'm going to take a picture of you, okay, with my cell phone right now. So everybody looks the same, right? Because everybody is a dot. Okay? I wait for 10 minutes and take another picture. So Sandy is going to move one chair. I take another picture. And I do this stuff over and over again. Obviously, the people in the next chair. But you take multiple pictures, and then what you do is you stack them. You put on top, and then you create an animation. And this technique is called astrometry. It's basically measuring the sky. So here, for example, you guys can see the asteroid? How many of you can see the asteroid? There's a guy. See the guy moving? That's Sandy. Okay. So how do we know where Sandy is? So what we do is just like how we have, you guys all use GPS, you guys have cell phones and stuff. Just like on the Earth, you have latitude and longitude, right? You guys have all heard of it. We have the same thing in the sky. It's called by a different name, right ascension and declination. So we use this information basically to try and find where Sandy is. So based upon where you guys are, because you guys are not moving, right? You guys are stars. I'll find where Sandy is at what time, okay? And I can measure her position across the sky. And that is nothing but her position around the sun. The orbit you saw, it's just a very tiny part of it. So if I wait for a few more months, she'll be somewhere else, right? So I can measure more positions, and I can get the orbit of the object. So that's essentially what we do. And here's an example of the computer program we use. Okay, we're going to play a game now. Okay, I'll have a few volunteers hold laser pointers. You got to be around the room. Okay, one more on this side, maybe something. Hold the laser pointer so in case people want. Here. Yeah, no, you should do it. Yeah. There you go. All right, so here's the asteroid we looked at before, right? Any guesses what this asteroid is? This is the warm one. A Ceres? Okay, she says a nearest object. Okay, somebody said Ceres. Good one. Close. Any more? No. Okay, it's Vesta. Okay, this is the largest asteroid in the asteroid belt. So I work on a spacecraft mission called Dawn, which actually went and took these pictures. Lucille was sitting here in the second row, actually in these images, for the mission. So, but even a big asteroid, this is about 560 kilometers across. It's a tiny dot, as you see from the Earth in most telescopes. All right, this is the game. So I'm going to show two pictures. Okay, you guys are going to tell which is the asteroid. All right, and anybody wants to tell the laser points around so you can answer for it. Okay, where's the asteroid? Hey, you gotta give it to the others. The people with laser pointers, your volunteers holding the laser pointer, not pointing it. Share it with others. Okay. Alright, that's the easy one. So, any idea which one is that? Ceres. Okay, this is the closest dwarf planet to the Earth. It's about 1,000 kilometers across. It's twice as big as Vesta is. Okay, here's a picture of here's the movie of Ceres from the Dawn mission. Okay, it's going to get a little bit more tricky. You're going to have more stars than that. Okay, this one. Ooh. Okay, if anybody wants a coin. Sandy, you can point. That one? Okay, blow it. Blow it. Alright. That was close. Alright.
That one, wow. Looks like my man. Look at what really missing.
Alright. Where is it? Okay, one last one, okay? Okay, how about this one? Can anybody tell what it is? It's a trivia question, okay?
ISS.
We're going to give the book out for this, okay? So, In 3, 2, 1. Anybody wants to guess? Satellite? Satellite, no.
Sedna?
Sedna, no. Who said Pluto? Yeah, yeah. Okay, you guess it. What's your name? Okay, the next one gets a meteorite, so. So why should we care? Okay, we mean, you know, you go out, this asteroid, this meteorites, who cares? You know, so we all know that about 65 million years ago, we had a big impact just off the coast of the Yucatan Peninsula in Mexico, which probably led to the extinction of the dinosaurs and gave rise to our own ancestors, you know, take root and, you know, survive. So it's about a 10-kilometer impactor, you know, that caused this event. And more recently, you can tell that closer to home, you have even the meteor crater. It's about 50,000 years ago. You had a 50-meter iron impactor. You know, how many of you seen the meteor crater? Good. Yeah. Those who haven't, go and see. It's a giant hole. Okay. And much more recently, this is the reason why we have Asteroid Day today. In 1908, we had, you know, a 60 to 200 meter object, probably a comet, came over Tunguska region in Siberia. So this object was an airburst. Airburst is nothing but, unlike you hitting something, it explodes up in the atmosphere, okay? And the pressure wave basically flattened all the trees around it. And it happened on June 30th, so that's the reason why we have Asteroid Day, okay? So this was in 1908. And then in 1994, we had the Shoemaker-Levy impact on Jupiter. How many of you were born or were alive when this happened? Okay, quite a bit. Okay, so this was a 2-kilometer comet. What happened was the comet was basically, it came really close to Jupiter. Jupiter's enormous gravity field ripped it off into 21 pieces, and you had all these tiny baby comets going around Jupiter. And over a course of a couple of weeks, they slammed into Jupiter piece by piece. So what you see here are marks, you know, bruises on Jupiter. So it's like a bar fight. You know, Jupiter got smacked, and then you see this stuff happening. And, you know, much more recently, you had you know, Chelyabinsk event in Russia. We were at the Gem Show, you know, the Gem Show was ending when this happened, and everybody was running to Russia because of this, you know, big event. Yeah, you had, you know, a 20-meter object actually, you know, explode about Chelyabinsk in Russia. So I have a piece of it. I'm going to pass it around. Okay, train break. So I'm going to pass it around. We've got to take it around. Be the chaperone of that. So there's a piece of the meteorite that came and impacted Russia, and so you can see it. Yeah, definitely good for the chaperone. It's expensive. Okay, so now we're going to play a game of fact or fiction. Okay, asteroid belt. Okay, what is this? This is a fact or fiction? Yeah. It's a fact. How is that in the fiction? Is the asteroid belt really like this? That's good, you guys are very smart. Okay. So what is it really? Yeah. Okay, I'm gonna watch it. Okay. So it's not really that way. The average distance between two objects in the asteroid belt is about 600,000 kilometers. Okay? So if you stand on one asteroid, you can't see the other one. Okay? There's no way you could, you know, fly the Millennium Falcon like that through the asteroid belt. Okay? Unless your asteroid has a moon. Okay? Important thing, asteroids do have moons. About 20% of the asteroids, 1 in 5 asteroids have moons. Okay? So if something comes and it's going to hit the Earth, there's 1 in 5 chance 2 things are going to hit the Earth. Okay, because it has a moon. Okay, here's a picture of Asteroida. Okay, it's baby moon called Dactyl. Okay, So this was actually imaged by the Galileo spacecraft when it was flying by, asteroid that would go towards Jupiter. Okay? All right, next one. How about this one? This one is the $1 trillion asteroid. Fact or fiction? Is it fact? So the story goes that, this asteroid passed by the Earth at 1.3 million kilometers, and then it was about half a mile across, okay? And then it was made of platinum core, and that is worth $5 trillion. And all the asteroid miners are salivating, like some of our dogs there. So, fact or fiction? Fact. Okay. Fact. Okay, we got a lot of. All right. So what happened was that they put these press releases out. This is what we call as low-hanging fruits. Okay, you can easily disprove this stuff by just going to the telescope. So what we did was, there's a giant radio telescope in Puerto Rico called the Arecibo Radio Telescope. It's one of the most important telescope assets we have on the world. So you can bounce off, radio waves off this asteroid, and you can find out how big it is. Is it really half a mile across? Yeah, it looks like it. It's about, 37% of a mile, so which is not too bad. Okay. Then what happens is that's where I come into the picture. I can tell what it's made of. Think of me like a prospector with a telescope. That's what I do, right? So we took spectra of this asteroid with a telescope in Hawaii. Okay. This is called a NASA Infrared Telescope Facility. It's one of the only telescopes on the Earth that NASA owns. Most of the stuff NASA owns is above the atmosphere. There's very few things on the Earth that they actually own, like a telescope. So this is one of them. So what we're doing is that we're trying to look at the sunlight reflected off this asteroid as it passes by the Earth. Okay? And what we do is that we know what the sunlight looks like, and then the surface on the asteroid absorbs certain regions of the light, and so we can tell what its spectrum is. So here, you can see the red line is actually the spectrum of the asteroid. The blue line is actually the spectrum of platinum, which all these people were salivating about. Okay? Obviously, it's not the case. Inverting, exactly. Okay, hot or cold? Okay? If you have a meteor, right, a meteor, if the Earth is going to be hot or is it going to be cold? Fact or fiction? Hot? Okay, hot. I got pretty cold. Cold? Okay. Yeah, it's about impact. So this is a news story that is about about a couple of months old. There was this forest fire just north of DC in Bowie, and then the firefighters basically went on Twitter and said there's a giant hole and there's stuff burning in it. It's got to be a meteor. Okay. The answer is it's never hot. Okay. So one of my jobs, I used to live in North Dakota, which means I used to be the one guy who look at meteors or meteorites. Okay, not many people in North Dakota, but every time I get a call, it's like, oh man, I was driving my truck and I saw the giant meteor. It hit the bar and started a fire. First time, the guy is drunk. Okay, so anytime you hear anybody say it hit something and started a fire, 9 out of 10 times it's a fake. The guy was smoking something. Okay, so what happens? Okay, so meteoroid, let's imagine our little rock. It first hits the atmosphere about 110 kilometers high in elevation. And as it gets down more and more, it gets hotter and hotter. So the bright part you see is at about 100 kilometers high. So then you actually see the stuff, 80 to 100 kilometers. And after that, it starts slowing down to about 30 kilometers. And afterwards, it's just in a free fall. It's just coming at it is simply a rock falling to the earth. Okay? The only thing that's going to move it or do anything to it is the wind, the prevailing wind. Otherwise, all the cosmic velocity is gone. It's just falling. And you guys might have seen when you go on the airplane, and you go really high, you try to lean against the window, what happens? It's really cold. That's exactly how the meteorite is. In fact, sometimes we have found meteorites that have frost on them, because they are cooler, so they can have stuff on top of them. So, so most meteorites are cold to touch. Okay? So here's another thing. So these are meteorites that fell from the Chelyabinsk impact. Okay? So this meteorite, okay, basically fell in February in Russia. It's covered in snow. So what happened was they basically slowly melted the snow and sank into deeper into the ice pile, the snow pile basically. And people who went to look for this, they took the whole hole and they flipped it upside down. So those are upside down meteorite holes. And they said, like, look, you were wrong because these are hot. That's why they melted. In fact, what happened was they were darker, so they were getting warmer by sunlight and slowly melting down. Okay, so most of the time, okay, like I said. All right, since we're in a bar, I thought I'd do a dare rather than trivia. Okay? Sweet or sour? Okay, how do meteorites taste? Anybody want to taste a meteorite? Oh my God. Oh wait, I got so many volunteers. We gotta have some way of doing this. Okay, how many of you think it's sweet? I mean, this is really expensive stuff. Okay, this is Murchison. Exactly, the guys who know this.
Oh, dear, I know what that is.
No, all right, so I'm going to give it to Dolores because she's qualified for it. The one thing is, can somebody get the napkin? Because you know what, this has some diamond dust. I don't want you to swallow it. Yeah, so she can spit it out. Okay, Dolores here works for Osiris Rex mission. She's qualified to do this. Do not do this at home. Okay.
I would never do this on the land.
Exactly. Can she get a napkin so you can charge you and spit it out?
Why would I spit it out? Eat it!
I got powder
One of
from
those zombies in
Nesta.
here, she can't eat
If
it.
somebody wants to try it.
All right, Dolores. Is Murchison all right? Yeah, probably the hand. There.
Yes?
Yeah. What is it going to be before she tastes it?
Sour.
Sour?
Dirt.
Dirt? Dirt? Yes. All right. Go ahead. How does it taste? Sour. I think I had a trivia question. Okay, one second. Where's my trivia? Oh, I missed the trivia one. Okay. We can have one more question, one more dare. Okay, then we can give this one up. Okay, another one. Who wants to taste a meteorite? All right. She can volunteer. Okay, what do you guys think? Sweet or sour? Or dirt?
Dirt is safer. I'm getting it.
Salty. Okay, this stuff is from Vesta. Okay, that's the biggest asteroid. It's a Euphrates. Alright, let's go.
Wait, it's like sand?
No, it's powdered. It's like 5 microns across. It's fine as you can possibly get. Yeah, don't start it. I can't guarantee.
That's for later tonight.
It tastes like cement, dry cement.
It tastes like cement. It's dry cement. That's
It's not sweet, but I don't think it's sour.
You know, you do realize you've eaten the oldest stuff in the solar system. You can't eat anything older than this. It's like dirt. It tastes like dirt.
Yeah. It tastes like dry cement.
All right. Yeah, that's the price. So she dared for it. She's going to get the meteorite. I am done. Okay. Questions? I got 2 minutes. Question here.
As far as the cosmic fire,
Yeah.
what is the impact of the surface area of fire?
Sure. So as far as the fire goes, why doesn't the impact heat up the spot where it's hitting and start the fire? Most of the time it's coming at terminal velocity, unless you like have like, you know, some kind of dynamite or something in the asteroid. You know, usually it's just like a rock falling to the ground. It'll create a crater.
Yeah. The parts that have propane tanks.
Yeah, if you have propane tanks on it, that would do it. You know, that would come. So, question.
How do you actually sense deeper than IR?
So how do you study the inside of the asteroid than just the surface with what we're doing? So I think radar goes a little bit deeper. You can also use gamma rays, which also interact with surface that is deeper. Then you can also do tomography. So sometimes you can have, you know, so you can actually, some kind of like a CT scan, you can do it, but you need more than one, you know, spacer to do it. You need to have something.
It says with neutrons and gammas, so you don't have to.
No, you don't need it. You can do it once. Okay, any more questions? All right, thank you so much.
And now we're going to have about a 5-minute intermission.